What exactly is machine learning? Well, machine learning is a subfield of artificial intelligence that allows for software applications to become more accurate at predicting outcomes without being explicitly programmed to do so. In more of a layman's terms, this is the capability of a machine to imitate intelligent human behavior. Typically, artificial intelligence and machine learning are seen as synonymous, and this is because most of the current advances in AI involve some sort of machine learning. It was defined in 1950s by an 8-year pioneer named Arthur Samuel. He described this as the field of study that gives computers the ability to learn without explicitly being programmed to do so. See, this definition still holds true today. Machine learning takes the approach of letting computers learn to program themselves through experience. This means that machines can recognize a visual scene, understand a text written in natural language, or perform an action in the physical world. Machine learning is behind chatbots, it's behind predictive text, it's behind language translation apps, the shows that Netflix suggests to you, and how your social media's feeds are presented. In order to understand exactly what machine learning is, we can explore some of its functions. I would say that there are three main parts to a machine learning system. The first is the descriptive. This uses the data to explain what happened in the past. So this may start with either numbers, photos, text, time series data, and then this data is gathered and prepared to be used as a training data. All the information the machine learning model will be trained on. So this descriptive analysis looks at data statistically to tell you what happened in the past. This descriptive function is very fundamental in machine learning as it allows you to explore the variables and attributes within your data set. The next function is known as the predictive analysis. This is where the system uses the data to predict what will happen in the future. Programmers choose a machine learning model to use, supply their data, and let the computer model train itself to find patterns or make predictions. We then move on to the third function, which is known as the prescriptive analysis. So this system will use the data to make suggestions about what action to take. Prescriptive analysis kind of takes predictive analysis to the next level. It basically asks, like, now that you have an idea of what will likely happen in the future, what should you do? And it suggests various courses of actions and outlines what the potential implications would be for each. It's interesting to note that the output of a machine learning system is a model that can be thought of as an algorithm for future computations. The more data the system is presented with, the more refined the model will be. And the quality of the learned model is also dependent on the quality of the data used to train it. So if the data is biased, for example, then the output of the model will also be biased. But we'll discuss this a little later. So why is machine learning important? There is a lot of data in the world generated not only by people, but now also by computers, phones, and other devices. Traditionally, humans have analyzed data and adapted systems to the changes in data patterns. However, the volume of data has grown so large that the ability for humans to make sense of this data is incredibly hard. So this is where we turn increasingly to automated systems. These automated systems can learn from the data, but also they adapt to like the shifting landscape, so they change over time. There are also multiple uses that machine learning can be applied to in order to do things for businesses, like cut costs, mitigate risks, and generally just improve the overall quality of life. With greater access to data and computational power, machine learning is becoming more important every day and will soon be integrated into many facets of human life. We can have a look at some applications that machine learning has. The first example is image recognition. Image recognition is the process of identifying an object or a feature in an image or a video. Image recognition has helped the healthcare industry vastly by improving diagnosing diseases like cancer with greater accuracy. Another application of machine learning that we see quite regularly is fraud detection. Fraud detection, basically through the analysis of images of like banknotes, machine learning algorithms detect patterns in financial operations and decide whether a given transaction is legitimate. Another application that I find really interesting is recommendation systems. So things like YouTube, social media, your Netflix account. These machine learning algorithms basically segment like customers based on their user data and behavioral patterns. So things like what you purchase, your browsing history, your likes or your reviews, and then targeted them with personalized products and content suggestions. Another application is text-to-speech systems, which can be used to improve accessibility for those with hearing impairments, disabilities, or aged citizens. Text-to-speech systems also has another name known as speech synthesis. So using a variation of machine learning called deep neural networks, which we won't discuss today, but we can use deep neural networks to basically produce artificial speech from text. So these are just a few machine learning applications. And through applying descriptive, predictive, and prescriptive analytics, we've been able to apply these methods to other ranges, to other fields such as transportation or retail. So we can move on to have a look and discuss how machine learning is different to classical statistics. Before moving on to discuss the methods of machine learning, I think it's important to elaborate how machine learning is different, but also similar to classical statistics. So I've summarized what I think are the important distinctions. Looking at the approach, from the machine learning perspective, the focus is on limiting assumptions. However, in statistics, these assumptions are made from algorithmic models, also known as statistical modeling. So statistical modeling refers to the data science process of applying statistical analysis to data sets. A statistical model typically is a mathematical relationship between one or more random variables and other non-random variables. So the application of statistical modeling to raw data helps data scientists approach data analysis in a more strategic manner by providing like visualizations that aid in identifying the relationships between these variables and making predictions. On the other hand, machine learning programs need large amounts of data and proper insights in order to function. They use this data to then build their models. This moves on to the focus. In a machine learning approach, we basically try to limit the assumptions to a minimum, and it will let the data almost speak for itself. Statistics, however, usually requires the statistician to make assumptions about the structure and or the distribution of the data, trying to guess the relationship between the variables in order to write an appropriate model. The last difference, which I think is quite crucial, would be between the inference. Machine learning models are designed to make the most accurate predictions possible, whereas statistical models are designed for inference about the relationship between variables. So yes, a main difference between machine learning and statistics is indeed their purpose. However, saying machine learning is all about accurate predictions, whereas statistical models are designed for inference, can be argued to be a bit of a limited statement. And this is because there is a difference between comparing statistics and then comparing statistical models. So yes, we can still examine the parameters of machine learning, and yes, we can still focus on the predictions and statistics. So the inference would be dependent on your approach as a researcher. It'd be dependent on the research questions that you have asked, your goals, your aims. And this kind of brings us on nicely to the overlap. It brings us onto this grey area. between the two. Personally, myself, I would not put a label on every single algorithm to fit within machine learning or to fit within statistics, because they are deeply intertwined and use many of the same tools, such as the computational techniques that I've mentioned. So in the end, when you're in the gray area between the two, the fact of doing statistics or doing machine learning often depends on the mentality that you use when approaching the problem. We can explore this gray area by looking at an example of a machine learning method known as regression. Through a statistical lens with regression, you would typically examine the variables and, based on the meaning, try to understand which ones might interact, which ones have some sort of linear dependency, and then build the model. However, through a machine learning lens, you might use a backwards elimination process of features, starting from a model containing every interaction. So this is letting the data decide which ones are relevant. So regression proves to be an example of both a machine learning method as well as a statistical method, because it uses not only the same computational powers, it uses the same skills, and also has this fundamental understanding of regression